The purpose of this video is on the overview of circles. Many of you have discussed circles in the past, but it's time to recap on a few of the basic concepts that you have not discussed for quite some time, I'm sure. So for the bell work here, answer each of the following questions about circles to the best of your ability. Question 1, how many degrees around a circle? Okay, there are 360 degrees. Number 2, what do you call the line segment that is connected to the center of the circle and the outer rim of the circle? Okay, that would be called the radius. Number 3, how do you find the circumference? Okay, so this is going back and recalling basic formulas that you should know. This is one that you will use in one of two manners. Okay, so you should remember C, or circumference, equals pi times the diameter, or pi d. Another form of that is also C equals 2 pi r, because the diameter is equal to twice the radius, or d equals 2r. So in that equation, we can replace the d with the 2r, and it's the same thing. Okay. Number 4, how do you find the area of a circle? That is A equals pi times the radius squared. Okay. It is important that you remember that when you square something, you take it times itself. It is not times 2, it is times itself. Okay, moving on. Features of a circle. For this, you're going to pay attention to several things. Okay, this is going to be throughout this entire unit. So first thing is a radius. Second thing would be chords. Third, diameter. 4, secants. 5, tangents. It's important to understand with secants and tangents, we are now talking about geometric, not trigonometric. Okay, so these are geometric secants and geometric tangents. Number 6, they're points of tangency, common tangents. And then later in the unit, we're going to discuss circumference and arc length, as well as area of sectors and area of circles. Okay, circles by definitions. A circle is a set of points in a plane that are all equidistant from a given point called the center. Okay. Naming a circle, this is something you'll have to do on the homework and on any kind of assessment that I give. If you are going to name that circle on the left, you name it by creating a small circle with a dot in the middle, indicating that that is the middle point or the center. So for that example, that is circle A. Again, you do have to have the little circle with the little dot next to the letter that is in the middle of the circle. Okay, so that is circle A. Radius, again, by definition, is a segment whose endpoints are the center and any point on the circle. Okay, so here I give two examples. Number 1, there you see the circle. I should probably put a dot on A there to indicate that that is the center of the circle, but I have not done that. So understand that assumption is not a good thing. So if you're ever in doubt, please, by all means, reach out and ask me a question. Okay, but A here is the center of the circle, and D is the center of circle 2. Okay, so for number 1, I would be looking for one of two things. All right, you do have the option. You need to identify the line or the radius here, the segment, as 2 points that are on that line or that line segment. Okay, here you have the letter A and the letter B, and I would prefer that they are presented in alphabetical order. However, if they are not presented in alphabetical order, it's not a big deal. Okay, so I would take one of two things. I would take AB, but you have to have the line segment above it, or I would take BA, again with the line segment above it. You have to have the line segment. That indicates to me that you understand that it is a line segment. It is not a line. Okay, it does not continue on forever. Number two, in a similar fashion here though, with D and C, we are looking for then CD as the alphabetical, or I would take DC. I don't like the way that looks. So DC. Okay, again, either one of those answers would be fine. Moving on to chords. Chords are any line segment whose endpoints are both on the circle. So for number one there, name the chords of the given circles. This is similar again in nature to a radius, that I have two letters. Preferably you would put them in alphabetical order, but again, if you don't, that's totally fine. Okay, as long as you use the two letters that are on that line segment. Okay, so number one, I would take, and preferred answer would be LM, but I would also take ML as an option. Number two, again, in similar fashion here, the alphabetical order would be NP. However, I would also take PN. Diameter. Diameter is a very specific chord that contains the center of the circle. Again, this is one of those things where on the examples I should present a dot in the center. Let's call it X for both of them. Okay, that way you know that it's for sure goes through the center of the circle because I'm identifying the center of the circle. But again, if you have questions about that, please by all means ask away. Okay, but here we're going to name the diameter. Again, it's similar to a radius and a chord. We're going to use two letters that indicate from that line or that line segment. And again, I would prefer them to be in alphabetical order. So for number one here, AB would be my preferred answer, but I would also take BA as well. Okay, but again, AB would be preferred. Number two, again, also similar, CD, which again is alphabetical. That would be my preferred answer, or again, I would take DC, because again, those are still two letters that are on that line segment. Secants, again, these are geometric secants, not trigonometric secants, if I can talk today. By definition, this is a line that intersects a circle at 2 points. Okay, so for the example here, I'm going to give you 3 different options actually as far as my answer goes. So we're going to name the secants of the given circles. Okay, so again, notice that these are now lines. They're not segments. They are lines that go through the circle and they cross the circle at 2 points. So if we look at number 1, this crosses here at F and again at G. Okay, so again, I have, as mentioned, 3 different things that I can do for this. Okay, F, G. Now the option on top here is a line with the arrows. Okay, again, this now indicates to me that this is a line, not a line segment. Okay, this would be the preferred answer if you give me the 2 letters. All All right, again, I would take this in reverse order. So I would also take GF, as long as it has the line with the arrows. But a third option here is, you'll notice that I have a lowercase, okay, italicized letter here at the end, okay? Uppercase letters indicate a point on that circle or on that line. So here, F, do it in a different color. F is this dot here. G is this dot here. But M is just the line itself. It is not a point on that line. It is the line itself. So another option here would be to write the word line and then put M. Okay, lowercase m, because that is what is given there. Okay, for number 2, similar to number 1, there we have 3 options. Option 1 would be to say DE. Again, with the line with the arrows on top, indicating that it is a line, not a line segment. Another option would be ED. And then the third option would be similar to this one, line N or M, because we have an M here and italicized. Here we have a N italicized, so this would be line N. Okay. You only need to name these in one of these fashions. As long as you have one of the 3, you are totally fine. Okay. If you don't have one of the 3, then we have to have some discussions. Okay. 2 more pages here. Tangents. Tangents, again, these are geometric tangents, not trigonometric tangents. This is a line that intersects a circle at exactly 1 point. Okay, so notice it's a touch and go. So here on number 1, you'll see that it goes from the left side, it goes to the point A where it touches the circle, and then continues. It doesn't go through the circle, it just touches it. So think about this as something sitting on top of a ball or something, let's say. If I take a piece of wood and sit it on top of a ball, then it touches it, it doesn't actually go through the ball, okay? A touches the circle, it does not go through the circle, all right? So here, you're gonna name the tangent. This is similar in nature to a secant. Again, I have 3 different options here because of what I'm presented. I have 2 points on here. Again, I'll indicate them in red. I have this dot here, and I have dot B. So my options here would be A, B. Again, line with the arrow, because again, this is a line. I could also have this in reverse, so BA would be okay. Or again, I have that lowercase italicized letter here, so I could say line P as my third option. Okay. Number 2, again, in a similar fashion to number 1, we have 3 options. I could put CD. Again, line with the arrows. I could put DC, I could reverse that. Or again, I have this lowercase italicized letter Q, which gives me line Q as my option. So again, 3 options for each of them. You have to pick one. Okay, point of tangency. Point of tangency is the point itself where the tangent line is touching the circle. Okay, so here all we're doing is naming a letter. All right, so for number 1, again, it's the point where it touches. So number 1, the point where it touches is D. Number 2, the point of tangency would be right here, which is point A. If you would prefer to write out point D and point A, that would be okay. But if you just give me the, again, capital letter there, not a lowercase letter, then you would be fine. Okay. Last topic of this section of notes are common tangents. Okay, these are fun. These are a line, a ray, a segment that is a tangent to two coplanar circles. Again, for some of you that have not gone through the material, coplanar just means that they are within the same plane. So if I have a stack of papers, then that plane, let me show one for an example here, then a plane is one of these sheets of paper. Okay, so the top sheet would be a plane in itself, and then the stack of them is just a series of planes. So coplanar means that the circles have to be on the same plane. So I would have to put both circles on the top sheet or both circles on the bottom sheet. I could not put one on top and one on the bottom and call them coplanar. They have to be on the same piece of paper, okay, same plane. So here we're going to identify how many tangents that we can draw that touch both circles only one time, however, still be tangent and not secant. Okay, so I want to see two things with these. I want to see the lines drawn. I also want to see the number in case you can't draw the lines. Okay, so number one, we actually have three of them. Okay, and those three fall here. One lies right on top. Okay. Some of you are going to want to get a ruler or something for a flat surface so that you can actually draw them fairly nicely. I do want to see them actually touching the circle like this. You'll notice that I did have to modify that first line because it didn't touch the second circle. Okay, and that's okay. But again, make sure that you correct it and modify that. A second line here would be on the bottom. Okay, so similar to the top one here, it's just on the bottom. Ooh, again, not a good line. That's better. Okay, and then there's a third line I said. So the question is then, where's that third line? Okay, if I draw a line over here, then it doesn't touch the other circle. If I draw the line over here, then it doesn't draw this circle. Okay, but I do have the ability to draw the line right here through the center. And these circles are going to touch each other at that one point, but they're not going to cross each other. Otherwise, they're going to be concentric circles. Okay? And it's not going to be a good thing. So here, I do have three common tangents. Again, I want to see both of those things. I want to see the number, the physical number, as well as the physical lines that you can draw for tangents. Okay. With that in mind, number two, then I would have how many? Okay. So I have two circles now again that are now separated. They're not together. I only have four different possibilities as far as how I can draw these. Okay, with two circles. The question is, how many do I have with this one? All right. So again, let's look at this one. So similar to what I had here, I have the ability to draw one on top that touches both of them, and one on the bottom that touches both of them. Okay, so let's go ahead and just draw those. So I have this one. That's a good line. And I have this one. Okay. And then the question is, are there any more that I can do? Okay. In fact, there are. There are four in total here. Okay, so I'm going to put the four here in the middle. And let's change the color to, I don't know, let's go with red. Okay, so kind of similar to what we did here. This one I could draw one that goes straight down in the middle. Here, I'm still going to have something in the middle, but I can't draw it straight down, obviously, because then it wouldn't touch both of them. However, I could do an X pattern. So if I have this, that is also a tangent, okay, a common tangent. And then I can do the other way here, touch the small one there, and the large one there. And now I have 4 common tangents. Okay, again, there are only 4 different presentations that I can give for common tangents. You'll see the other 2 throughout the assignments and the assessments at some point in time. So make sure you understand these. And then, as always, with all of these things, if you have any questions, comments, or concerns, please, by all means, reach out and let me know.